We're going to write the equations of tangent lines today, which we've done, but we're just going to do it now where you've got to do the product rule in your derivative. So for number 1, we're going to use x squared plus y cubed equals -7 to find the following. So for part A, we want to find the point on the graph. So that's the ordered pair. That's like the -1 comma something. So we're looking for the y value. So the y value always uses the regular equation. So I'm going to take -1, plug it in for x, and solve for y. So -1 squared is 1. So that'll be 1 plus y cubed equals -7. And then subtract the 1. And that'll give me y cubed equals -8. Then to solve for y, I can just take the cube root. So this is what number to the third power is -8? That would be -2. So the point on the graph is -1, -2. Then to find the slope, we need to look at the derivative. Okay, so remember, slope is always the derivative. So we're going to have to go through our implicit differentiation. Okay, we don't have to do product rule with this one. So that'll be 2x plus 3y squared, and then this one gets a times dy dx equals the derivative of -7, which is just 0. Then to solve for dy dx, I would just move the 2x over and then divide by what's being multiplied with the dy dx. So I would divide by the 3y squared. Now to find my slope, I can plug in -1 for x, -2 for y. So from here, m will be -2 times x, so -1 over 3 times -2 squared. So that'll give me +2 on top. That'll give me 4 for the -2 squared, times 3 is 12, and that'll reduce to 1/6. So the equation of the tangent line is just going to be my y minus y1, so minus a -2 equals m times x minus a -1, so x plus 1. So when you need the y value, use the original equation. When you need the slope, use the derivative. Now let's look at number 2. So this time all we want to do is find the slope of the tangent line. Okay, so they've already given us the x and the y value. Okay. I'm going to rewrite my square root of y as y to the 1/2. Okay. When I do the derivative here, I'm going to have to do product rule. These two will just be regular derivatives. So we'll have for the square root of y, 1/2 y to the -1/2, and then I did a y derivative, so times dy dx. Then I'm going to have to do product rule here. So f is 2x, f prime would just be 2, g would be y, so g prime would just be a 1, but then times a dy dx since we took the derivative of a y. So we're going to have the derivative of square root of y plus f times g prime, so 2x times 1 is just 2x, and always tack on that dy dx at the end, then plus f prime times g, so that's just 2y. Okay. So this term right here was my f g prime, then plus that term right there was my f prime times g. So then that's that derivative. Then we have to take the derivative of x squared, which is just 2x, equals the derivative of -10, which is 0. Okay, so I'm going to leave these two over here, move those two over, so that will give me -2x minus 2y. These two I'm going to GCF out the dy dx. Okay. Then since this one has a negative exponent, I'm going to take the y, move it down to the denominator, with the 2, that'll make the exponent positive, and then plus a 2x. Okay. Then to solve for dy dx, I'm just going to divide by this. So that'll be negative 2x minus 2y all over 1 over 2y to the 1/2 plus 2x. Okay. And then from here we can plug in our x and our y, but I've got a fraction in fraction. So I technically do not have to simplify it since this isn't my answer, the slope is my answer, but I find it easier to plug these numbers in if I get rid of the fractions in fractions. So the denominator is a 2y to the 1/2, okay, so I'm going to multiply everything on top by 2y to the 1/2 and everything on the bottom by 2y to the 1/2. So distribute this in. That'll give me negative 4 xy to the 1/2. Then 2 times 2 would be a minus 4. This time I can add those exponents. So 1 plus 1/2, that's 2 halves plus 1/2. So that'll be 3 halves. Over here, that's just going to cancel and leave me with the numerator. And then this will give me a 4x y to the 1/2. Then from here, to find the slope, I'm going to plug in negative 2 for x, 4 for y. So that's going to be negative 4 times negative 2, and then it'll be 4 to the 1/2. And remember, 1/2 means square root. Then minus, this is y to the 3/2. So remember, it is power over root. Okay, so I'm going to take the square root of 4 to the 3rd power. And it's actually easier if you do the root first. So I'm going to rewrite this as the square root of 4, and then I'm going to cube it. And then on the denominator, I will have 1 plus 4 times x times the square root of y, so the square root of 4. So right here, this is going to give me negative 4 times 2, which is 8, times square root of 4, which is 2. So that'll be 16, minus square root of 4 is 2, then cubed is 8. So I'm going to have minus 4 times 8, so minus 32. Over, this will be 1. I already figured this part out. That's 16 from earlier. So this will end up being negative 8 times 2. So 1 minus 16. So that's going to be negative 16 over negative 15, which will reduce to positive 16 over 15. Let's look at one last example with trig in it. Okay, so find the equation of the tangent line at the given point. So we've got 2 cosine of x sine of y equals 1, and they've given us the x value is pi over 4, and they're telling us y is between 0 and pi over 2. So that just means our y value is somewhere in quadrant 1, okay, because we know this is 0, this is pi over 2. So y's got to be somewhere in here. So first thing I'm going to do is find the y value. So plug in x. So that'll be 2 times cosine of pi over 4 times sine of y equals 1. So I need to evaluate cosine of pi over 4. So that'll be a 1 root 2. So cosine is going to be adjacent over hypotenuse, so 1 over root 2. And then since I can't cancel those, I'm going to go ahead and rationalize the 1 over root 2. So that'll be root 2 over 2, and then I'll be able to cancel those 2's. So then these will reduce. That'll give me root 2 times sine of y equals 1. Then I'm going to divide by root 2, and then I've got sine of y equals 1 over root 2. So then once you've gotten sine by itself, you can solve. This is our opposite over hypotenuse. we know y is only in quadrant 1. So normally we would take a positive sign and put it in quadrant 1 and in quadrant 2, but they tell us y is in 1. So my opposite would be 1, my hypotenuse would be root 2, so it would be this same angle right here. So in this case, y is also pi over 4. So then that's going to make this ordered pair pi over 4, pi over 4. Okay. Then to find the slope, I need to take the derivative. So I'm going to have to do product rule here. So f is 2 cosine of x. So f prime will be negative 2 sine of x. G is sine of y. So g prime is just cosine of y. But then times dy dx, since we took the derivative of something with a y. Okay. Then I'll take this, plug it in to my f, g prime plus f prime times g. So that's going to give me 2 cosine of x times cosine of y with the dy dx plus negative 2 sine times sine, so that would just be minus 2 sine of x sine of y equals the derivative of 1, which is just 0. Okay. Then I'm going to leave this term over here, and I'm going to move the 2 sine of x and sine of y over, and then I'm going to divide by the 2 cosine of x, cosine of y, and then I can cancel the 2's. Okay. And what else I'm going to do on this one, because I think it's going to make it easier to plug these in, is I can reduce sine of x over cosine of x. That's tangent of x. So these two we can combine because they're the same variable. Same thing here. Sine over cosine is tangent, and since it's both y's, we can simplify this. Okay? And you don't have to do this. I'm just doing this because it'll be easier to just do tangent of pi and pi over 4 and tangent of pi over 4 instead of having to do sine times sine divided by cosine times cosine and simplifying. So then when I go to find the slope, I'll do tangent of x, which is pi over 4, and tangent of y, which is also pi over 4. So I can go back to this angle. So tangent is opposite over adjacent, so that'll be 1. That will also be 1, making my slope 1. So I will have y equals, I'll have y minus y1, so minus pi over 4 equals 1 times x minus pi over 4.